Hello, 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 hello. Hello, my dear students. Welcome back to my YouTube channel. I hope I am audible and visible to all of you. Am I audible? Hello. Am I audible? Hello. Not getting your response, so I hope that I am audible. Am I audible? Hello. Not getting your response, so I hope that I am audible. Am I audible? Hello. Okay, so let's start now. First of all, I need to check whether my screen is visible to you. Not getting your response, so I hope that I'm audible. Now it is visible. Am I audible? Hello. Okay, so I need to check it out. Let's start now. First of all, I need to check whether my screen is visible to you. Not getting your response, so I hope that I'm audible. Now it is visible. Am I audible? Hello. Okay. Yes. So I need to check it out. Let's start now. First of all, I need to check whether my I guess is visible to you. This screen is also visible to you. So I hope that I'm audible. Yes. Now it is visible. One second. Am I audible? Hello. Okay. Yes. So I need to check it out. Let's start now. First of all, I need to check whether my I guess is visible to you. This screen is also visible. Done. Just provide me one minute so that I can just fix all these things. Then we can start the kinematics, right? 1 second. So let us continue now. Let's start. Okay. So as you know that we will be discussing the very first lecture of class 11. That is my kinematics. If you want to ask me anything, you are most welcome. Okay. So let's start. Look now. As we discussed earlier in my Telegram group that we will be discussing 11th chapter on YouTube, that is free, right? And for paid classes, you need to reach out to me via the Telegram. There we will be discussing how I will take your one-to-one sessions or one-to-many sessions. Based on that thing, we have designed a course there. So if you want those lectures, you need to connect it with me. There we will start paid courses, right? I'm having two courses right now. One is the paid, one is the free one. So free one will be on YouTube and paid one will be on Zoom classes. So right now we will be discussing kinematics. Kinematics. So what is kinematics? Kinematics means study of motion. It is study of motion. Study of motion. Of what? Of object. Study of motion of object without considering its cause. Sir, what is the meaning of it? What does kinematics really means, right? Suppose this is my ground. Okay, the dash means we are standing on the ground. Here I am having a ball. Simple statement. Here I am having a ball. This is my ball. Done. With mass m, we applied some force to this ball, force F. We applied some force. Let's suppose a person kicks the ball. Okay, now initially ball is at this particular point. After some point or after some time, your ball is here. Finally, you will write it S or X distance. This ball covers X distance. And you will write here speed of ball with which it crosses this X distance is, let us suppose, V. Okay. Look, here are two things that we need to study. First thing, when the person kicks the ball, then this ball came into the motion. First statement. Second statement is when the person kicks the ball starts rolling. That means ball comes into the motion. Then it covers some distance with some speed. So what is the cause of this motion? Sir, we can see from this particular thing that the cause of the motion, cause is this force. This person is cause. If the person has not applied the force F, we cannot say the ball crosses the distance x. So the cause of this motion of the ball is the force. So in kinematics only, we are considering or we are interested in dealing what? In dealing with speed. In dealing with speed. In dealing with distance covered by your particle. We are not interested in knowing the cause of the motion. We are not, no? We will be not considering its cause. The statement says that steady of motion. You can see steady of motion, but without considering its cause. We are not interested in letting know the cause of this motion. We will be not ensuring its cause. Simple, easy. Let's see your comments now. Done? Okay, now. So up to this particular point, I guess each and everything is now clear to you. What is kinematics? Basically, we are done with it, right? Now, second point, we will be discussing frame of reference. We will be discussing frame of reference. I guess this is not good one. 1 second. Frame of reference. Frame of reference means set of instructions. Suppose in frame of reference you are having coordinate system. A coordinate system. Frame of reference is the collection of coordinate system plus observer plus watch. How, sir? I will write it in this way. We know this is x-axis, this one is y-axis. Okay, and this particular point means origin. This one is known as origin, so I will write here a person is standing at the origin here. On this hand, we are having a watch. Why there is a usage of watch? Because to know the timings. Now suppose a person is here. Suppose a person is here. A person is here. So you were right. It is coordinate came out to be, let us suppose x1, 0. Now I am seeing my watch. I am the observer. I am seeing the person's observations, right? And it is at x1, 0. Now I am saving the watch after 1 minute or after 2 minutes or after so many times, right? Now it is initial position. Now it is finally the person is here. It is at x2, 0. x2, 0. Finally. So what you will observe here? You will observe that, sir, at initial position was x1, 0. After some time, its position is x2, 0 now. So coordinate changes. What changes? Sir, coordinate changes. Coordinate means position changes. Coordinate simply indicates position changes. So you will write here position changes with respect to time. So if coordinate or if position changes of your person with respect to time, we called the situation as, so you will write if position changes with time. So the person is in the motion. If not, then rest. Simple definition. Easy definition. If position changes, the particle or the object is in the motion. If position doesn't change, that means the person or that particle is at the rest. Easy? Done? I will give you one example of it now. One example. Example is, now sir, let us assume a bus. Let us assume a bus. Let us assume a bus. Tire of bus. Okay. Bus is going towards the right side with some speed v. We are having a person. Look here. We are having a person. Person is here. One observer. Observer first. This is my person. This one is my observer first. Observer first. Here we are having observer second on the ground floor or different side. Observer second. Observer second. Now, for observer first. For observer first. Okay, for observer first. Initially, he is seeing. For observer first, na, look, for observer, for this observer, this observer is seeing this person. Initially, the person is standing in front of the observer first. After 5 kilometers, the same situation is present now. The person is standing in front of the observer first. So, sir, you can see no position changes. No position changes. No position changes. So, for observer first, this particular person is at rest. So, I will write for observer first, person is at rest. Person is at rest. But what about the observer second? But what about the observer second? Now you can see initially for observer second, you can see, look here. For observer second, now you can see person is here. After some time, your bus will be here now. So you can see first position and second position of your bus. It changes. So you can write here. What you will write? You will write here for observer second. You will write here for observer second. For observer second. For observer second, person is in motion. So these statements are now contradictory. How, sir? At a particular instant, person second is in motion and person is at rest. How is it possible? It is only possible when motion and rest is defined. It is only possible when motion and rest, it depends. You will write motion and rest depends from the observer point of view. So you will write motion and rest depends on frame of reference. Depends frame of reference. The means these are not absolute terms. Not absolute. One more example. Suppose I am standing here, right? For you, I am at rest. But for different person who is in this space on the surface of the moon, right? He knows that we are revolving, we are rotating. So for that person, I am still in the motion. But for all of us, we are at the same particular position now. That means we are at the rest. But for the observer who is outside the space, he is seeing us in the motion. That means motion and rest can be used differently according to the observer's point of view. This was all about rest and motion. This is all about rest and motion. Okay, now let us start now. Types of motion. Let's start now. Types of motion. Types of motion. Types of motion. Generally talking about, so we are having three types: 1D motion, we are having 2D motion, we are having 3D motion. Okay, let us talk about now 1D motion. 1D motion. 1D motion is also known as straight line motion. Straight line motion, or it is also known as one dimensional. One dimensional means only one coordinate changes. One dimensional motion, are also known as a rectilinear motion. A rectilinear motion, if only one coordinate changes. Example, suppose this is my building and I am dropping a stone from this particular edge. I'm dropping it. Okay, so you were right. Dropping a ball. Example of 1D motion. Only one coordinate changes. No, only x changes. Sorry, only one changes. Only y coordinate changes. Only y coordinate changes. That's why it is known as 1D motion. Clear? Or if your car is going, it is going with some speed v. Also, this thing is also known as 1D, one dimensional motion. 2D. 2D means two dimensional. Two dimensional motion. Done? Or curvilinear motion. Curvilinear motion, in which two coordinate changes. If you want to write some examples, so we will write here projectile motion. So what is projectile motion? Look now. If you are here, you are kicking a ball, you will find the ball will go in this way. This is known as projectile motion. This thing is known as projectile motion. Projectile motion. Clear? Or second one, if you are rotating something in a circular things, okay, the ball is going in circular things, right? So you will write here circular motion. Circular motion, both projectile motion and circular motion, type of 2D motions. Now 3D. 3D means three-dimensional motion. Okay, 3D means three-dimensional. Three-dimensional motion, or motion in space. Motion in space. So you will write here motion in plane also. Motion in plane. Plane means 2D, space means 3D. And if you want to write the example, let us suppose we are having birds, flying of birds. So you will write here motion of birds. Motion of birds. Or dust particle motion. or dust particle. These things belongs to, or motion of a kite. Okay, this thing belongs to three-dimensional motion. Three-dimensional motion. Done. So now we are done with types of motion. We are done with motion and rest. Now let us start distance and displacement. Let's start now. Distance from this particular end, I will write displacement. And we know these things from our early classes. We know these things from our 9th classes. Okay. First point. Distance means the actual length of your path. That means how many steps you have taken. Actually, how many steps you have taken. The length of that actual path is known as distance. So you were right here. It is actual path length. Path length. Actual path length. In given time. In given time. Second part. Distance is a scalar quantity. Scalar quantity, only magnitude is considering important parameter, or only magnitude we are taking to define the distance. Number 3, distance never decreases. Distance never decreases. You cannot say that I have taken 4 steps, so then I have taken 2 steps backwards, so 4 minus 2 is 2 steps. No, so it will count your steps. Let's suppose you are going in some path. Okay, you have gone four steps ahead, so you will write 4 steps is your distance. Then 2 steps backward, 4 plus 2 6, you will write 6. Every time your distance will increase, it will not decrease. If distance is 0, that means you are at rest. So distance never decreases. If it never decreases, so it is never be negative. Never be negative. Distance never be negative. Fifth, if distance is equals to 0, if distance is 0, object must be at rest. Object must be at rest. Must be at rest. 6th point. Between, look, if you are having 2 points, point number A and point number B, 2, you need to go between 1 and 2. You will take one path. Look, this is one path. You can go in this way also. You can go in this way also. You can go like this also. You can go like this also. You can go in infinite ways. So infinite ways. Infinite possible ways to reach point second. Infinite possible ways to go to final position. This was all about your distance. Now if we talk about displacement, displacement is the shortest path. Shortest path between 2 points. It doesn't mean that whether you have gone from that. Let us suppose it is point number 1, point number 2. You have taken this path. Okay, but you will join these 2 ways by a very shortest way. Shortest way means you will go in a straight way. We know that you have not gone from this way B, but still you have to write displacement is B. It is an imaginary path. So it is the shortest path. Whether you have gone from that path or not, it doesn't depend on it, right? It should be the shortest path between the 2 points. So displacement simply indicates the shortest path between 2 points. As the distance is scalar quantity, displacement is a vector quantity. Vector quantity. Displacement is a vector quantity. It needs direction as well. So look here, distance never decreases. You were right here, displacement increases, or it can decrease also. Fourth point, never be negative. My displacement could be positive, my displacement could be negative, or my displacement could be zero. We will be defined numerical, there you will get these things done. Fifth point, if displacement is zero, so if you write if displacement is zero, if displacement is zero, it is not stated that it must be at rest. It indicates that object crosses initial position. Object crosses initial position. Or initial position and final position is same. Point number 6. Infinite possible, only one possibility. Why? Because you can write or draw only one possible shortest path. Look, only one shortest path. So by this thing we concluded our distance and displacement. Let us draw some graphs by which we will be having very good knowledge regarding distance and displacement. Done? Graph number first. Between s means distance, t means time. One graph. First graph. Possible or not, you have to answer me, right? Second graph. Second graph. Third graph. Third graph. Fourth graph, and fourth one is very important because it is between displacement and your time. You need to tell me whether these graphs are possible or not. You can see here, look, as we know that if we are making something like this now, this thing means positive, this one is negative, this one is positive, this one is negative. So I guess this particular thing represents minus s, minus distance. So, and we know from the previous thing, minus distance is not possible. So this graph is not possible. Look, you can see here, this distance is increasing. Now it is increasing, right? It is increasing here. So, but if it reaches this particular point, then it decreases. And we know that distance never decreases. Right here, distance never decreases. If distance never decreases, so this graph is also not possible. Now this graph number third. In graph number third, you can see now it is going increasing. No, it is only increasing. Rate is different, but it is increasing only. So if it is increasing but rate is different, no, but it should be increasing, no, not decreasing. If increasing, so this graph is possible. Now if we talk about this now, so this particular thing means minus displacement, and minus displacement is possible. Displacement is decreasing and displacement is decreasing, that is also possible. So you were right here, sir, this graph is possible. So graph number third and graph number fourth possible, and graph number first and graph number second is not possible. Done. So we had completed a frame of reference, motion, rest, types of motion, distance, displacement, and these curves. Now let us talk about one most important thing, that means a vector, a displacement vector. Now displacement vector. I will change the pen now. I will write here displacement vector. Displacement vector. Suppose x-axis, y-axis, let us suppose we make a z-axis also. It is z-axis or z-axis. Okay. First position is this one, position number A. Coordinates are x1, y1, z1. Final point is B. Coordinates are x2, y2, z2. Now we know that this point is in the space, so we have to draw a position vector. This position vector is OA vector. And the position of B from the origin means OB vector. We are going from A to B, so my displacement will be from A to B. That is about delta S vector. How to find delta S? You can see it makes a triangle now. Look, one vector is A. On A we are having one more vector, that is delta S, and we just joined vector A and vector ds by OB vector. OB, na? This one is OA. So it is a triangle law, right? So you will write here OA plus delta S equals to OB. So therefore you will write delta S came out to be OB vector minus OA vector. You will write like this. Okay. Now look here. Look here now. Delta is OB. What is OA? What is OA? Sir, OA is x I cap, x1 I cap plus y1 j cap plus z1 k cap. What is OB now? OB is x2 I cap plus y2 j cap plus z2 k cap. What is OB minus OA? It will be equals to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So that means delta S displacement is equals to change in x I cap, change in y j cap, change in z k cap. This thing means your displacement. So you will write here, this thing represents your displacement vector. This thing represents your displacement vector. Displacement vector. Done now? Now let us start now the numerical practice of these things now. Suppose numericals, right? First numerical is, if particle starts from, if my particle starts from 1, 1, meter, and this particle goes up to the point 4, 5, 13 meters. First point, what should be the initial vector? Initial vector or initial position vector? Initial vector means OA. OA. What is OA? Sir, OA is x I cap or x1 I cap plus y1 j cap plus z1 k cap initially. And you can see initially the particle was, so instead of x1 I will write 1 I cap. Instead of y1 I will write 1 j cap. Instead of z1 it is 1 k cap. So I will write here, it came out to be I cap plus j cap plus k cap. Done. Now, second point, what will be the final position vector? What is final position vector? Final position vector. Final position vector is x2 I cap plus y2 j cap plus z2 k cap. Okay, so x2 is 4 I cap plus 5 j cap plus 13 times k cap. Third point, if I ask you find the displacement vector, find displacement vector. Displacement vector. So what is displacement vector? Displacement vector is x2 minus x1 I cap plus y minus y1 j cap plus z2 minus z1 k cap. x2 is 4 minus 1 I cap. y2 is 5 minus 1 I cap, j cap. z2 is 13 minus 1 k cap. It came out to be 3 I cap, 4 j cap, 12 k cap. Clear? Okay, now if somebody will ask you what should be the, it is magnitude. Magnitude. Okay, so the magnitude will be 3 square plus 4 square plus 12 square root. 3 is 9, 4 is 16, 25 plus 144. It could out 25 plus 144. So what do you write here? Look, 4 plus 5, 9, 4 plus 2, 6. So I guess my answer came out to be 13 meter. 13 meter is my answer. So these things that we discussed now, what is displacement vector, all these things now. So in this numerical, we conclude how to write the right approach, how to write the initial position vector, how to write the final position vector, how to write the displacement vector, and how to find the magnitude of that displacement vector. Look, a square plus b square twice b cos theta, but angle is 90, so a square plus b square only. That's why 3 square plus 4 square, 12 square. You will find how magnitude of from vectors lectures. Okay. Done. Okay. Next part. 1 second. One more numerical, and with this numerical you will get one thing clear, that how distance is always more than or equals to displacement. We are having a path. Let us suppose we are having a path. This is my path. It's my path. Point number C. Point number O. Point number B. Point number A. 3 meter from A to B. 5 meter from B to O. 4 meter from O to C. Find our distance and displacement. Distance and displacement. Done. So we have to find out. I will make here a diagram or a simple thing, that is distance. Then displacement. Person goes from O to A, then O to B, then O to O, then O to C. When person goes from O to A, person goes from O to A, O to A, that means from this point to this point, O to A, O to A. What is distance? What is the actual length that a person covers? I guess the actual length is given as, it is given as, for O to A, it is given as 3 meter. Short path is also 3 meter only, right? One person goes from O to B, O to B. From O to B, O to A. No, O to A is different now. O to A. Oh, one second, beta. One second. First of all, person goes from O to B. Then goes O to A. Then it is going from O to B, B to A to B. Then it goes from O to B, B to A to B, B to O. Then it goes O to B, A to B, B to O. This is my origin. Origin means 0, 0. Here we are having positive x-axis, here we are having negative x-axis. O to B, if person goes from O to B, it covers our distance 5 meter and displacement is same as 5 meter. O to A, it is 5 plus 3. That is 8 meter, displacement is also 8 meter. It goes from O, starting from O, goes to B, then O, then B. It is 5 plus 3, 8, 8 plus 3, 11. 11 meters. But if we talk about displacement, initial point is 0 and final point is B. Initial point 0, final point is B. What is the distance between 0 and B? It is 5. So I will write here 5 meter only. Now from O to O, it goes from 0. O means O, then B, then A, then B, then O. It is 5 plus 8 plus 3 is 11. 11 plus 5, 16. 16 meters. You can see here initial point 0, final point is over 0. You will write 0. So 0 is the answer. Now, if we write from O to B to A to B to O to, let's C. Okay, it is 16 plus 4, 20 meter. So you will write here it is 4 meter, but in negative direction. So now you can clearly see here distance. My distance is always increasing, always increasing, always increasing, always increasing. Okay, but displacement 5 to 8, it increases, then it decreases, then 0, then negative. You will write here it increases also, it decreases also, it came out to be 0 also, and it came out to be negative also. So from this particular thing, so we can write one thing, that distance is more than or equal to displacement. Okay, distance is every time more or equal to displacement. It is always. Okay, starting the new numerical, and my numerical will be like, if we are having a circle, think like this. Now I will break down the whole circle into 4 equal parts. Okay, look, radius is r. That means this side is also r, this one is also r, this one is also r, this one is also r. Point number A, point number B, point number C, point number D. First part, find distance and displacement. So we need to find displacement or distance also. A part, going from A to B. If particle goes from A to B, what is distance? Okay, so you will write if particle goes for whole circle. For whole circle, what should be distance? Look, if particle starts from this particular point, now, if particle starts from this particular point, right? And particle goes along this circumference of the circle and came back towards point A. So what is the distance? Distance means it will be the circumference of the circle. That is 2 pi r. For complete circle, so you will write here for complete circle. For complete circle, it is equals to 2 pi r. And we divided the complete circle into 4 equal parts. So can we write the distance traveled by your particle? It will be 2 pi r divided by 4. It will be pi r by 2 only. Done. So what will be displacement? So this one is what? Distance. Done. Now let us talk about displacement now. Displacement simply indicates you need to join initial and final point. Done. Initial, final. Initially is A, finally is B. You need to join these two lines. Now see, it came out to be a right angle triangle. It is a right angle triangle now. So you will write here, it came out to be r square plus r square root. It came out to be r root 2. So my displacement came out to be, it is r root 2. Now, second part, B. If particle goes from A to C, for A to C, it is half of this circumference. So you will write 2 pi r divided by 2. My answer came out to be pi r. So pi r is my distance. Pi r is my distance. Now for displacement, what could be my displacement? So displacement means if you want to connect the two extreme ends, this end and this end, just join these two ends, so you will find 2r. It is 2r. C point, it is AD. What is now distance? So distance is 3 parts. 3 parts now. So look, 2 pi r is total. 2 pi r is total. So what I need to find out? 3 parts out of 4. So I will write 3 by 4. 3 by 4 of whole. So I will get 3 pi r by 2. My distance. So what could be my displacement? Nothing. We need to join initial final, no? It is it is AD, right? It is A and D. Join these two things now. So what you will get? You can see by your own eyes. It's also a right angle triangle. RR, it could have to be R root 2. So you will write here displacement. Displacement is equals to how much? It is R root 2. Now final point, it goes from A to A. So if A to A, what would be distance now? So distance could be 2 pi r only. And what would be displacement? I guess displacement will be equal to 0. Yes. So this is how we need to tackle with the problems. Easy problems. Okay. Easy or super easy numericals? Easy or super easy? Give me 1 second now. Okay, now one more numerical. So I will write the language of the numerical now. Language, okay? A cyclist. A cyclist moving on a circular track of radius 1 meter. Completes one revolution in 10 seconds. Then find out its displacement after 1 minute and 5 seconds. Numerical, like we are having a cyclist. Cyclist is cycling cycle on a circular track of radius 1 meter. Okay, it completes one revolution in 10 seconds. That means it takes 10 seconds to complete one complete revolution. We need to find out its displacement after 1 minute 5 seconds. 1 minute 5 seconds. So look how we can do it now. Look, 1 minute I can write it 60 seconds. 60 seconds minus 10 seconds plus 10 plus 10 plus 10 plus 10 plus 10. One revolution. Third, fourth, fifth, and sixth. A revolution simply indicates, look, if it starts from this particular point, initial and final point is same. So what would be displacement now? Sir, for complete circle, it takes 10 seconds. 10 seconds. And for complete circle, the initial position and the final position is same. So you were right here, displacement came out to be 0. It is 0 plus 0 plus 0 plus 0 plus 0 plus 0. For 1 minute, displacement is 0. Now for 5 seconds, if it takes 10 seconds for complete revolution, for 5 seconds it will go half. And the radius is, this much is 1 meter and this much is 1 meter. And what will be displacement in diagonals, in opposite terms now? It would be the diameter of this circle. That means 2 meter. So my displacement came out to be, my displacement is equals to be 2 meter. So extra, if you need to find out distance now, it would be 6 times 2 pi r plus pi r. It will be 13 times pi r. 13, pi is pi and r is 1. My answer is 13 pi meter. My answer is 13 pi meter. Okay, so we got know how to find distance now, how to find displacement now. Done? Easy? Easy now? Okay, now. So we will be starting now the direction properties. Direction now. Direction. Direction. I cap minus I cap. J cap minus J cap. K cap minus K cap. Minus K cap. These are my directions. I cap means east. If you want to write, you will write here. This means east. This part means west. This one is north. This one is south. This one is up. This one is down. Up, and this one is down. Okay, let us see. Firstly, am I audible and visible? 1 second. Either my comments are not visible. I need to check no comments. If there is any comment now, then we will start. 1 second. Only NEET. Srinidhi, no, it is not only for NEET, it is also JEE means, right? But not advanced level. If you are following these things, right? For means, for JEE means, for your board exams and NEET now. Only my course are only designed for 3 examinations: NEET, board, and your JEE means. Okay, if you are from these 3 particular things, you can qualify, and you can just watch my videos. Hasna beta, hello. Shrinis Kumar, hello sir, time enough है क्या नीट क्लियर करने के लिए? But time तो बहुत है ना. If your basics are very clear, right, then you are having more than enough time to watch these things and to practice. हम बहुत पढ़ा सकते हैं, लेकिन that doesn't mean ना कि you can get with those things. If your definitions or if your derivations or everything is very clear to you, okay, then your NEET is very easy to qualify. But if you are lagging basics, then you need to put some extra efforts. Muhammad Wahib, not it, beta. But I will just text you, right? Very soon I will be with you, na. Don't worry about it. So let us continue. Okay. Now look, kahan the hum? Okay, so now we are dealing with the directional properties. Very important now. East means I, west means minus I, north means J, and south means minus J. Up means K, down means minus K. Okay. 1 second. Okay, now look here. बहुत ध्यान से देखिएगा. Look now. We are having one special angle that is 45 degree. 45 degree means middle. Okay, suppose let us do only 2 axes now. Generally now it is plus I means east, minus I means west, plus J means north, and minus J means south. If we are having 45, look now, I am drawing anything like this, a line. You can see this angle is 45 and this one is also 45, because total is 90. If I am drawing something like this, if I am going something like this, but this line should be in between, angle should be 45 degree. So look, this line is between north and east. You will write northeast, or you will write east north. No issue at all. Northeast or east north. Look, this line, second line, this line is between southeast. You will write southeast, or east south. Okay, if you are having a numerical, a particle goes 10 meter northeast or 10 meter east north, same thing. Now what this one now represents? west to south. So you will write here west to south, or you will write here southwest. This one you will write here northwest, or you will write here west north. But it is only valid for 45 degrees. Only valid for 45 degrees. Sir, if we have different angle rather than 45, how we can deal with those angles? Look now. Look, beta. Very easy. Look now. See now. If I am having something like this, okay, east, south, I'm having angle. Let's suppose the angle is with 60 degree. Look now. One more. If this angle is 60 degree, east, south, how to write it now? How to write it? Sir, I am having 60 degree with south. So you will write here 60 degree east of south. Side to which your line is matching, you need to write it at the end. Look, east of south. That means east of south means your line is between east and south, and it is with, the angle is with the south angle only. Okay, now this one now. We know it is between 60 degree. Now it is 60 degree and it is between east and south. But you need to write out south of east. South of east now. Okay, one more now, and I hope you can do it now. -30 now. East, north. So what you will write this one? Sir, it is 30 degree north of east. Okay. This one now. West north. You hear? 30 north of west. You can see now I am going from the basics. I am teaching you like you are right now coming from 11th. You are coming from 10th and going to 11th. This small details I am teaching you now from very basics. I am not considering you know anything from 11th. I am considering that you came first time to 11th now. That's why I am teaching you that simple things. Okay. Now we done standard displacement. Then we conclude some numerical based on that thing also. Now we done the graphical things, the directional properties. Now we will merge these two things. We will merge distance displacement with direction, and we come on to the doing different numericals, right? So let us suppose we are having a numerical, a very interesting numerical, a very good and interesting numerical. A numerical will be a merger of distance displacement with this particular directional properties. Numerical is find net displacement, and you will get notes in my Telegram group. Find displacement, find a net displacement of a particle. Find net displacement of a particle moves as given. First path 5 meter due east. 5 meter due east. Second part 10 meter 37 degree south of west. Third part 20 meter 53 degree east of south. East of south. First particle goes 5 meter due east. Then from that particular point, particle goes 37 degrees south of west 10 meters. Then from that particle goes 20 meter 53 degree east of south. Sir, due east means only east. 37 it is south of east means it is between. Na? So look now, this part I will write here. So this part, it is 5 meter. It is 5 meter due east. 5 East means plus I cap. Meter. Now this one, now it is southwest, so I will make southwest now. South of west, so angle would be somehow here. This is 10, so this would be 10 cos 37 minus I cap. This would be 10 sin 37 minus j cap. So 37, it is 10, 37 minus 4 by 5. 5 minus 5, 5 2, 10, 4 2 is 8. It is 8 minus I cap. It is 10 sin 37 minus, it is 3 by 5. 5 minus 5, 5 2 is 10, 3 2 6. It would be 6 minus j cap. Okay. This one now, it is east of south. East of south. 53 degree 20. So this side would be 20 cos 53 degree. This would be 20 sin 53 degree plus I cap minus j cap. So look now, 20 cos 53. Cos 53 would be 3 by 5. 5 minus 5, 5 4 20, 4 3 12. It is 12 minus j cap. 20 sin 53 is 4 by 5. 5 minus 5, 5 4 is 20, 4 4 16. It will be 16 plus I cap. Now look, we are having 5. So I will change the color so that you don't get confused from it. So I will write here, it is 5 I cap. So I will write 5 plus I cap, or 5 I cap simply, plus now it is 8. I can write 8 minus I cap, then 6 plus 6 is minus j cap, plus we are having 16 I cap, 16 I cap, then it is plus 12 minus j cap. I cap, I cap, I cap. 16 plus 5, 21. Then 21 minus 6. Is it 21 now? I get 13, no? So we are having plus 13 I cap. Done, done, done. It is minus 6, minus 12, minus 18. It is minus 18 j cap. So this is my displacement. This numerical is combination of displacement and combination of your directional things now. If somebody will ask you what should be, it is magnitude. It is magnitude is equal to 13 square plus 8 square. 13, 169, 64. Then 1 second. No, it is 18. No? Sorry, it is 18 here. It is 18 here. 1 second, beta. It is not, it is 18. It is minus 18 j cap. It is 18 square. 169 plus 18. 18 means it will be 3 to 4. 3 to 4. So it will be 3. Then 7, 8, 9. 4. 493 root. That means it will be 22 something. 22 meters. Okay. This is my final answer. Final answer. Final. So that means it is I and j. J, and j is how much? It is 18 j cap. So what is tan theta now? P by B. What is perpendicular? It is 18, base is 13. So my theta, final theta came out to be tan inverse 18 by 13. This is how you need to do these numericals. Easy or super easy? Easy or super easy? If you're watching these lectures, right, don't waste your time. Do the calculation by your own now. Okay? I am not coming here to give you the such simple numericals. No, you're a grown-up child, right? You are coming from 10th now. And you are preparing, you are not preparing for some different examinations, some simple one. You are preparing for some competitive now, some national examinations. So you will get a good numericals in your examinations. So to get a good rank, to get a good numericals in your examination, you need to be very good prepared for your subject. Okay, I have given you only one step, but now I have given you 3 steps because I want your analytic brain to be very great. Okay. So now I will be giving you 2 homework numerical, and I will be posting the solution also, or we will discuss these numericals tomorrow. Then a person moves 50 meter due north, then 40 meter due east, then 20 meter due south. Find displacement. Find displacement. So I will write here the answer of this numerical so that you will just see your numerical. Displacement came out to be 40 I cap plus 30 j cap. It is mod came out to be 50 meter. And it is theta or direction came out to be 37 degree north of east. First homework. I hope you have noted down this one now. Okay, you can take the screenshot of this numerical also. Okay, now next numerical. Next numerical. Also second homework now. A particle moves 30 meter due north, then 20 meter due east, then 20 root 2 meter due south or southwest. That's southwest. Find displacement. Second homework, solution. It is displacement came out to be 10 j meter. It is mod is also 10 meter. Then so I will be writing homework numericals only and then we will stop. Okay, because we complete the standard displacement direction tomorrow, or from next lecture we will be starting speed. Next lecture, speed, velocity, acceleration complete. Right, third homework now. Okay, tomorrow is holiday, so you are having a very great time. A monkey, a bandar, a monkey running in a garden. Moves 30 meter due north, then it takes 90 degree right turn and moves 40 meter. Finally climbs on tree of height 50 meter. Find magnitude of displacement. Find magnitude of displacement. And answer for this is 50 root 2 meter. take the screenshot of this numerical, or if you are writing this numerical, pause it and write this one now. Last numerical now. Last homework from today's class. A wheel of radius r is placed on a horizontal surface and it is contact point on ground is P. If the wheel starts rolling without slipping, and completes half revolution, then find out magnitude of displacement of point P. Answer of this numerical is r under root of 4 plus pi square. These are numericals. I guess I have given you 4 to 5 numericals, and I hope that you can do these numericals by your own. Okay, and if you find any difficulty, next class you need to ask me these numericals. And also I am coming with the new series for 12th one, the numerical top 100, top 200 numericals from each chapter. Okay, only on the weekends, and we will continue our sessions of 11th. If you are having any other doubts, or if you're having any other kind of things, right? And for online batches, paid batches, if you want to connect with me, you are most welcome. You need to send me the links, or you need to just connect with me via, one second beta. Okay, so you need to send me message on Telegram. So I will be in the class for 2 minutes. If you are having any doubts, if you want to ask me anything, you are most welcome. I don't think you are having any doubts now. Okay, so if you want to connect with me, just write message on Telegram. And thank you. Bye. Take care, Beta. Good night. Bye. Good night, Beta.